Hey folks, Monty here today with Vinicius Electrik to talk to you about their Lizard module. The Lizard module is a multi-function hybrid analog and digital module capable of operating as an oscillator, a sequencer, and an audio switcher, and is the flagship module from Vinicius Electrik and the cornerstone of their 104 HP complete Lizard system. The Lizard is divided into two sections, each with a dedicated output. The upper section functions as either a multimode oscillator that produces everything from your basic analog style waveforms to complex custom waveforms with lots of motion, or an analog style 8-step sequencer. The lower section functions as an 8-input analog audio switcher capable of generating complex waveforms based on what is fed into it via these 8 inputs at the bottom. The audio switcher is a slave to the frequency of the upper section and behaves differently in both oscillator and sequencer mode. The function of the Lizard module is determined by this 3-position switch in the middle of the top row of the module. When the switch is in the lowest position, we are in VCO mode. The middle and the top positions put you in sequencer mode, with the rate being set by either an external or internal clock respectively. To coherently explain this module, I will discuss VCO mode first. To the left of our 3-position switch, we have a frequency and fine knobs which control the coarse and fine tuning of our oscillator. To the right of our 3-position switch, we have a type and mode push buttons for determining how the VCO is actually going to behave. The Lizard VCO can operate in 6 different modes, each with 4 different types of those modes. The 6 different modes include Wave Drawler, LFO Drawler, Superwave, Phased Saw, Wave HD, and Chord modes. I will be discussing each of these modes more in depth either later in this video or in future videos depending on how you're watching this. Below the top row we have 8 potentiometers whose functionality is determined by the mode of operation. Below this we have a row of inputs and outputs. We have a DX style linear FM input with the depth controlled by the FM width knob to the left. We have a CV input for keyboard pitch, a dedicated square wave output, a hard sync input, and 2 outputs, with out 1 being dedicated to the top section and out 2 being dedicated to the audio switcher. Mode 1. Wave Drawler. The Wave Drawler is one of the more unique features of the Lizard module and is capable of generating complex and harmonically rich custom waveforms. As the name suggests, this mode actually allows the user to draw in their own unique waveforms using the 8 potentiometers. This mode can best be compared to an 8-step sequencer being run at an audio rate. Another way to consider this is to imagine a single cycle waveform divided up into 8 segments, with the amplitude of each of those 8 segments being determined by the 8 potentiometers. While each of the pots are labeled with a range of 0 to 10, they are not actually stepped and have a near infinite number of positions, allowing for a near infinite number of different custom waveforms. Let's take a look at the oscilloscope to better understand what's actually happening. I'm going to start with each of the 8 pots in the 0 position. As you can see in here, we are not yet producing any sound. As I turn pot 1, you can see I am now generating a very narrow pulse wave. If I continue to add steps sequentially, I can increase the width of said pulse wave. However, as you will see later when we discuss mode 5, the Lizard is capable of generating pulse waves without this type of hassle. This mode is best utilized to generate complex waveforms you can't get most other places. Let's have a listen. As I mentioned earlier, each of the mode has 4 different types. In mode 1, the type determines the order in which the module reads through the potentiometers to draw your wave shape. Type 1, or forward, reads from pot 1 through pot 8. Type 2, or backwards, reads from pot 8 to pot 1. Type 3, forwards and backwards, reads from pot 1 to pot 8, and then back, creating a symmetrical and sometimes formanty type of sound. Type 4 reads through randomly and essentially turns your lizard into a digital noise source. Mode 2, LFO Drawler. The LFO Drawler is very similar to the Wave Drawler, except instead of generating 8 static steps, each of your 8 steps is tied to a triangle LFO. The rate of that LFO is determined by the position of each of the 8 potentiometers. Let's again turn to our oscilloscope to figure out exactly what I'm talking about. Again, we will start with each of the pots set to 0. In contrast to mode 1, however, you can hear that we are generating sound. That's because the amplitude of each step is always in motion. The 8 potentiometers set the rate of the oscillation of each step, not the amplitude, with 0 being slowest and 10 being fastest. Let's see what happens as I increase the rate of some of these steps. As you may have figured out, because of the nature of this mode, the oscillator is in constant motion. The LFOs are not synced to each other, and therefore the sound is always evolving, and it is essentially impossible to ever generate the same wave twice. The 4 types within this mode are the same as in mode 1, with type 1 reading through potentiometers from 1 through 8, type 2 reading from 8 to 1, type 3 from 1 to 8 and back to 1, creating a symmetrical wave, and type 4 again reading through randomly, turning your lizard into a digital noise source. Mode 3, Superwave. In Superwave mode, the lizard is capable of generating up to 5 simultaneous oscillators. 1 master oscillator, whose frequency is determined by the CV and FM inputs as well as the coarse and fine tuning knobs, and 4 additional oscillators, whose frequency deflection and volume levels are determined by the 8 potentiometers. Though the additional oscillators have their frequency deflected from the master, they are still slave to the master frequency, thus producing a timbre similar to a classic sync-type sound. Pots 1 through 4 determine the frequency deflection of each additional oscillator, and pots 5 through 8 determine the volume level, thus allowing you to mix in each additional oscillator. Let's have a look and a listen. As always, I will start with all 8 pots set to the 0 position. The actual wave shape is determined by the type. We'll start in type 1, which generates a sawtooth wave. With all of the pots set to 0, you can see that we are simply making a classic saw wave. As I adjust pot 1, you can hear that still nothing is happening. However, as I turn up pot 5, you can see that I am increasing the volume of this additional wave. I can do this 3 more times, with each additional wave having its own deflection and volume control. As I mentioned, the base wave shape is determined by the type button. Type 1 produces sawtooth waves. Type 2, triangle waves. Type 3, pulse waves. And type 4 produces what we call a supersat wave, which is a wave shape unique to the lizard system. Mode 4, Phase Saw. In phase saw mode, the lizard is capable of generating up to 5 sawtooth oscillators simultaneously, whose equations and phases are manipulated using the potentiometers. In this mode, the 4 different types determine the number of additional oscillators added to the mix. In type 1, we have 2 simultaneous oscillators, one master sawtooth oscillator, whose frequency is determined by the CV and FM inputs, as well as the coarse and the fine-tuned knobs, and one slave oscillator, whose deviation and phase are determined by pot 1. In type 2, we have 2 additional oscillators. In type 3, 3. And in type 4, you guessed it, we have 4 additional oscillators, where the deviation and phase are determined by pots 1 through 4 respectively. In this mode, pots 5 through 8 do not do anything. Let's take a look at our oscilloscope and hear some sounds. I will start us in type 1, and as always, all of the pots are set to 0. As you can hear now, the sound is very static. As I gradually turn up pot 1, you will hear the phasing offsets begin to happen and motion enter the sound. And I'll switch us to type 2. We now have 3 VCOs going. Type 3. And finally, type 4. Mode 5, Wave HD. In this mode, the lizard generates your classic analog style waveforms. While this is a digital oscillator, the conventional waveforms are sampled at an extremely high sample rate and thus produce very accurate recreations of some of our favorite sounds. In this mode, the type selector determines the wave shape. Type 1 produces sawtooth waves, type 2 triangle, type 3 sine, and type 4 pulse wave. In this mode, the potentiometers do essentially nothing, with the one exception being that in type 4, pot 1 is used to adjust the pulse width. Let's have a listen. We'll start with our saw wave. Triangle. Sine. Pulse. Mode 6, Chord. In chord mode, the lizard generates chords of up to 5 voices. The root note is determined by the CV and the FM inputs, as well as the coarse and the fine tuning knobs. Up to 4 additional notes can be added to your chords utilizing the potentiometers. Pots 1 through 4 determine the note offset, and pots 5 through 8 determine the volume of the additional notes respectively. The additional notes are quantized to semitones for easy tuning and have a range of 15 half steps, or from a C to an E flat. In this mode, the type selector determines the wave shape. Type 1, sawtooth, type 2, triangle, and type 3, square. In this mode, type 4 is its own unique thing that works closely with the audio switcher, and we will discuss that later in this video or in future videos depending on how you're watching this. For now, let's listen to some sounds. I'll start us in type 1, or sawtooth wave, and as always, with the potentiometer set to 0. I will gradually add one note at a time to build our chord. Type 2, triangle wave. Type 3, square wave. Sequencer Mode 1. In Mode 1, the lizard behaves similarly to a classic analog-style 8-step sequencer, with each step being determined by the respective potentiometer. As in VCO mode, this control voltage is output via the dedicated output number 1. While running as a sequencer, the square wave output can be utilized as a gate signal and can be used to trigger your envelopes or whatever else you may want to trigger with each sequencer step. As in Mode 1 Type 1 as a VCO, the type selector determines the order through which we go through the steps. Type 1 forward cycles from step 1 through step 8. Type 2 backwards cycles step 8 to step 1. Type 3 forwards and backwards cycles from step 1 through step 8 and then back to 1. And type 4 cycles through randomly. Let's have a listen as the lizard sequences the multi-waves module. Sequencer Mode 2. Mode 2 as a sequencer is similar to Mode 2 as a VCO, however the module is not cycling through the steps at an audio rate. Instead of using the potentiometers to set the level of each step is tied to a triangle form LFO whose rate is determined by the respective potentiometers. Mode 2 is typically used as a modulation sequencer as opposed to a pitch sequencer. Again, the type button selects the order through which we move through the steps. Type 1, forward, cycles from step 1 to step 8. Type 2, backwards, cycles from step 8 to step 1. Type 3, forwards and backwards, cycles from step 1 to step 8 and back to 1. And Type 4 cycles through them randomly. Let's have a listen to an example. In this example, I will be using the lizard to sequence the cutoff frequency of the filter. Our multi-waves module will be the VCO. Audio switcher. The audio switcher is the analog section of the lizard module and behaves differently as a VCO and a sequencer. It consists of 8 analog inputs and a dedicated output. While this section has its own functionality and a dedicated output, it is still tied to the upper section and the tuning is slave to the master tuning for the entire module. As a VCO, the audio switcher produces complex wave shapes based on the signals fed into the 8 inputs. It does so by cycling through and sampling these inputs at an audio rate and outputting the resultant waveform. In other words, it produces a wave shape of 8 parts, where each part is drawn based on the momentary sampling from the respective input. These inputs receive either audio or DC level signals from nearly any source, and an input with no cable inserted is grounded. Let's listen to an example for how this can be utilized. The audio switcher as a sequencer. Since both sections of the module have dedicated outputs, the audio switcher is still functioning while the module is in sequencer mode. In fact, understanding how the audio switcher behaves as a sequencer can make it easier to understand what it's actually doing as a VCO. In sequencer mode, the audio switcher cycles through each of the 8 inputs with each step of the sequence. In fact, this is exactly what it's doing as a VCO. However, as a VCO, it's cycling through these 8 inputs at an audio rate, and your ear cannot hear the individual steps. As I mentioned earlier, each of these 8 inputs can receive both audio and DC level signals. Let's have a listen to some examples.